So, welcome to Expressions and Equations 3. This video, we're going to be touching upon combining like terms, which is something we did a little bit of in Expressions and Equations 2, but we're going to look at it more in depth. It's something that we pretty much always do if we're changing an expression, simplifying an expression, is we're going to make it shorter by combining like terms. So say we have a look at this expression, negative 2v plus 3 plus 5v minus 1. And we want to model it. We can use what's called algebra tiles to model this expression and see what it might look like visually. So we have two types of terms. We have our variable terms, which are the longer blocks. In this case, we have negative 2v on the left in blue, and then we have 3 small squares. That's representing positive 3. Then we have 5v in green, so green is positive, and then blue, a negative 1 square on the right. So this is how we could model an expression using algebra tiles. They have different sizes because they represent different types of quantities. So there's variables, and then there's constant terms, which are not variables. So this can be useful to see what combining like terms is. How can we put these different pieces together? They're basically like pieces of a puzzle. How can we kind of reorder them? Imagine they're on the table. What do we have when we do that? So this is what we started with, negative 2v plus 3 plus 5v minus 1. So if we reorder these tiles and we just place them in different places, we can put same size tiles together, or in other words, same types of tiles together. So here we've put all of the v, the variable tiles, on the left, and we have negative 2, and then we have positive 5. And then on the right we have positive 3 and negative 1, and those are just constants, just 1, 2, 3, and negative 1. Then if we look and see what cancels, so the red circles represent 0. So we have negative 2v and positive 2v in the red circle on the left, and that makes 0. They cancel. And on the right we have negative 1 and positive 1. That makes 0. So those cancel. So what's left, what's not in the red circles, is the result. So this is called combining like terms. And what we started with was negative 2v plus 3 plus 5v minus 1. But now we see that just the only thing that's left is 3v tiles. So we have these 3 on the left, and we have 2 constant tiles. So the answer would be 3v plus 2. So maybe you could think about this again. These algebra tiles are really useful to kind of think about what's going on with combining like terms. So the expression negative 5p plus 6 plus 4p minus 5 is laid out here. We have our negative 5p on the left, and then plus 6 in the middle, plus 4p, and minus 5. These 4 different parts, since we have 4 terms in our expression. So what would this make when we combine them? So again, here's our picture. Negative 5p plus 6 plus 4p minus 5. We're going to rearrange those tiles. We've got all the variable tiles on the left, some negative ones and some positive ones. We've got all the constant tiles on the right, some negative ones and some positive ones. And then see what's going to make 0. Sometimes things cancel out and make 0. So these red circles again represent opposites. So what's not shaded out is what we have left. And so this expression is going to simplify to negative p plus 1. So see how you did there. So usually, we don't use algebra tiles to reorder and add like terms because we don't always have them available. So we just do rewriting on the paper. So if we are looking at this expression, which has 5 terms, the terms just don't come in the right order, so they don't match their like partners. Negative 5 minus 4f plus 9 minus 3f plus 2. We want to rewrite that by shifting them around. Just like we're moving around the tiles, we move around the terms. So in red, we have the 3 constant terms, negative 5 plus 9 plus 2. And in the second set of parentheses, we have the variable terms, negative 4f and negative 3f. So if we then add each set, in the red, we have negative 5 plus 9 is 4. 4 plus 2 is 6, so we get 6 for our constant term. And negative 7f comes from negative 4 and negative 3f in the second set of parentheses in purple. And that would be our variable term. So those are 2 sets of like terms. We could rewrite it. Sometimes we want to write it in a reverse order. So if we use the commutative property, we could change what we get to negative 7f plus 6. Sometimes that's optional. If you're looking for like multiple choice answers, you might need to do that. Again, we're adding coefficients basically when we're combining like terms. So negative 4f and negative 3f, you just add negative 4 and negative 3 to get negative 7. So a second example, very similar. We just have fractions and decimals, and so we have a lot of different types of problems we can do. But again, we have 5 terms in this expression with a and b, some terms with a and some terms with b, and they're out of order, so we want to make some groups. So here's our groups. We have 1/2 a minus 2/3 a, and second group is 2.5b plus 3.7b and negative 0.3b. You could write just minus for the last term, but sometimes we use addition of the negative number. And again, adding those 2 groups, 1/2 minus 2/3 is negative 1/6 a, and in the second group, these 3 decimals would add up to 5.9b. So that would be our result, negative 1/6 a plus 5.9b. So here's a couple of problems for you to try. And give you some time to think about them. What would these 3 expressions simplify to? So how would you reorder the terms to make groups of like terms? And what would you get when you combine the like terms? I'm just going to walk away from the video for a minute, and then I will show you the answers at the end. So do this on your note-taking sheet. All right, so I hope you had enough time to think about a few of these expressions and see what they would be equivalent to. So let's just see what we've got.
Hey, Rob.
Yeah.
Hey, are you okay for me to switch?
Sorry about that interruption. First expression, I don't show the grouping here, so I skipped that step so that you would hopefully write that, but when we add the three terms with m in them, we're going to get 77.39m plus 15. Second expression, the answer would be negative 22k plus 10r plus 19, so there's three different types of terms there. There's r terms and k terms, and then the 19, which is a constant term, so we can't combine those further. And the last expression would be 1/4 of j plus 1.5k. So we have some options here since there's decimals and fractions to write just fractions or decimals or a mixture. Usually we would try to do just fractions, I would say. So unless you can't figure out what the fractions are, you can definitely write decimals, but either way is fine. They're both equivalent. So see how you did, and hopefully you're getting the hang of combining like terms. It's important to note that we cannot combine these further, right? So if we have a variable term like 77.39m, we don't know what that is because we don't know what m is. So we cannot add it to 15. And sometimes students want to do an extra step to kind of condense it down to just one term. We can't do that. So it's important to recognize that things are unlike terms. Variables and constant terms are different.